Hello, good time zone, everybody. So that's what we internally say. I want to say GitPod, but now I have to get used to the new 3 letters. So at ONA internally. Very happy to have today with me Chris, our CTO and co-founder, and Patrick Rice, so a long-time customer of GitPod and ONA with Kingland. And we will talk today a bit about our joint experience in rolling out coding agents in a more regulated environment. You folks, I think, are CMMI 5 certified organization. Probably touch on that as well today. So really grateful to have both of you here. Let's probably start off with a short introduction and then dive in. We have 30 minutes. The first 20, 25, we try to make this a very informal fireside chat, and then also want to open it up for Q&A for the audience. So welcome everybody that is also watching. Chris, maybe you wanna kick us off with a quick introduction for myself, Johannes, CEO and co-founder of Now ONA.
Hi, I'm Chris. I'm CTO and co-founder of Now ONA. Over to you, Patrick.
Excellent. Well, thank you for the excellent introduction. My name is Patrick. I'm an enterprise architect at Kingland. I've been with Kingland for about 15 years. And like Johannes said, longtime customer of previously GitPod and now ONA. I also have to get used to the new name. So hopefully I don't use the old one accidentally.
That's okay. We are all in that transition period, so we decided internally there will be a time period where there will be some chaos. So definitely okay if there will be some GitPod references today. Let's start this with looking a bit how AI has impacted software development, which I've never seen something like that, given the pace and the level of impact which happened over the last years. So internally, when we look at it, we divide it in roughly 3 phases. The first one is, let's call them coding assistants. I think GitHub Copilot pioneered that, and is the tool that most folks are familiar with. The second one are AI editors or AI vs code forks, as we also say internally. Cursor, I think, is something that people know. And right now, we feel we are at the cusp and at the beginning of more truly agentic systems. Devin, I think Claude Code, and also ONA are an example of that. Chris, maybe to start with you, because we've ourselves, of course, we dog food our product, so we've gone through that like evolution internally. Walk me a bit through that adoption curve and what we've seen internally and where we are right now.
Yeah, we've gone through these 3 phases ourselves. So the very first phase, all manual, every line artisanally crafted, save for autocomplete and code generation. And here's a pattern, if the engineer stops working, no more work happens. And then along came Copilot and Cursor, and we were very quick to actually mandate Cursor throughout the organization and made it so that everyone used Cursor specifically for the tap autocomplete. This was before the days of Cursor Agent. And what we found was that things accelerated, not massively, but they did accelerate. So this pattern of artisanally crafted lines, you now get more autocomplete and you get faster autocomplete. But it's fundamentally the same pattern. Then along came Claude Code, and we were, again, very quick to adopt that to a point where then we also mandated that everyone use Claude Code. And this third wave of agents where code gets autonomously produced really fundamentally changes the pattern, because now it's no longer the engineer's attention that is producing the code, but it's the agent. What we then saw, though, is this pattern of when I close my laptop or I want to go and do something else still remains the same. It's just one instance of that agent working. And once we had ONA agents in a state where it was useful, we very rapidly saw a transition to owner agents. And this time around, we didn't mandate it. In fact, the Cloud Code mandate was still in effect, and people just ignored it and started to use owner agents. And the main driver here was convenience. It's simply the fact that you can fire something off, and the agent is going to do its thing, and eventually it's going to come back and be like, hey, I'm done. And then as a user, you can pop into VS Code right there and then, and in the same pane of glass, basically on the same page, and examine the work. And this is just such a fundamentally different way of working that even without us pushing for it, we saw rapid adoption. And today, Ona is the #1 committer in our repo. And we're seeing very direct correlation between throughput in terms of PR and code at flatlining mean time to recovery and change failover rate with folks using Ona.
I can personally say that Chris himself got quite addicted to it. We will touch on that later. Also, our PRs that are open, that metric also rose. So new bottlenecks are emerging, and looking forward to talk about that as well. Patrick, how have you seen that? I think there are a bit more constraints also in the environments that you folks are operating in. So how has that adoption been for you?
Yeah, absolutely. I would say a similar adoption path on our side as well. So, multiple years back, I love the term of artisanally crafted code. We call it lovingly handcrafted code. But every line touched by an engineer explicitly. And I will say probably maybe a year and a half ago, we looked at adoption of code suggestions and that kind of autocomplete flow through AI. And we see tons and tons of usage of that, even still to this day, with hundreds and thousands of lines of code suggestions coming through on any given day. And so, we still see a lot of adoption of that, but we are also seeing now a shift towards the agentic side. And it's especially powerful both for, entry-level engineers or even senior engineers joining a code base for the first time, trying to understand what they're working with in that code base, but also very expert engineers who really understand the code base can give excellent prompts to an agent and get it to generate and create for them something that it may have taken them days to write by hand. So really seeing that same uptick a little bit more slowly, because again,
we're also biased. We are very biased here.
For sure. And we have very strict regulatory requirements around ensuring that humans look at every line of code, that it goes through a reviewer. That human in the loop is very, very important to us. And obviously very strict regulatory requirements around ensuring that these agentic models run in a private space for us, so that our code is secure and there's no risk of an AI model being trained on our code. So it's great to see products like Ona Agent come out that offer that experience.
Yeah, I think like having no egress for source code is something that we see a lot in our customer base, which is very, very, very important. And to double click a bit on what you said, what are specific use cases that you see? Because sometimes I think it's difficult for people to really have understand tangibly what you can do, because ultimately it's a prompt box and you can do a lot of things with it. So we really try to always also carve out like specific use cases where you've seen success with more agentic systems and Ona in particular.
Yeah, absolutely. There's a couple great areas for agentic flows. So one that we find a ton of success with is actually code maintenance. Teams where you have linters or CI/CD pipelines, and you're like, man, I would really love to add another rule to my lint, because this problem can be handled by a linter and it's driving our engineers wild. Well, you have this fundamental problem when you enable a new linting rule, which is, do you go through and you ignore all of those previous linting findings and you just let them be for a while? Or do you try and remediate a lot of them before you enable the rule? ONA agents and agentic workflows in general kind of changes that to almost have a third role in there where you can enable the rule and then ask an agent to remediate as many of those findings as possible, leaving only sort of critical or maybe highly intertwined findings left for a human to review. So it's a lot more respectful of the human engineer's time when you're enabling these types of new linting rules. Another one that we've seen is, in a similar vein, library upgrades. All of us rely on open source tools at some level, and open source tools release new versions and they have release notes that break things. So being able to provide an agentic tool those type of release notes combined with a repository that has a great CI/CD pipeline to make sure that it doesn't break something becomes really, really powerful at being able to resolve those very quickly. And then, of course, we actually have used ONA not just for the creation of new features, but actually for designing and prototyping those features in the first place. So knowing that you'd like to make a change to your code base, but you might not know exactly which files you need to change, especially if you have a code base that's, let's say, 15 years old, 25 years old. It's great to be able to let an agent kind of spin through that code base and identify areas where you might need to make that change to affect the feature that you're looking to affect. These are things that would have taken, again, hours or days for a human engineer to do. And speaking as a human engineer, are not always the most fun tasks to do. But it's definitely a significant lift and to be able to use agents for that type of thing.
Yeah, can agree. So CVE updates, dependency management, like code refactoring, general quality improvements. We see a lot. Given your CMI5 organization, there is like a lot of also compliance requests and mandates that you have to fulfill. Looking a bit in the future, what do you think is the most like soul crushing toil that you would love the machines to take over and take away from your engineer's plate?
I mean, I think you kind of you knocked on it with CVEs, but again, any software of sufficient size has quite a few dependencies that it uses, and it's got a reasonable attack pattern for things like static analysis, dynamic analysis, and SCA scanning, which of course everybody should be doing, but we are mandated and audited against those expectations to make sure that we do those and to make sure that we resolve the findings that those things those identify. And I know that is something that really, really acts as a drag on not just engineering productivity, but also in some cases just the mental energy of engineers who analyze and resolve those. So we have to make sure that we're compliant, which again, human in the loop is very, very important for us. But I'm really excited about the ability of agents to be able to pick those things up and to help us generate increasingly more secure code.
Makes sense. Chris, we talk about this internally a lot, but we believe it's very, very important to point or to paint a very exciting future and vision where there is very close and strong human and agent collaboration happening. And as everything is changing, because it really is, I think the IDE was always the tool, and it still will be important. But we had culture wars around VI, Emacs, etc., and those things probably will not happen in the future. How do you think will the role of an engineer evolve over the next years, and what is the role of an IDE, and what tools are we actually going to use to write software together with more agentic flows?
Yeah. The engineer's job has essentially always been to understand value that you need to create, value for the business, and then break that down into bits that can be codified in source code. That's fundamentally the job of an engineer. And I think expressed this way, this job will remain. So very fundamentally, doing this translation work is the same. The thing we translate it into changes. So the way we specify this codification changes. So in like at this point, almost old addendum that the new programming language is English, I think holds some truth. However, the abstraction below English that is today's programming languages, I think will remain for the foreseeable future. For one, there's a lot of inertia in adopting new technologies.
Yes.
So, we'll still be talking about Java in 10 years, love it or hate it. And with that, the tools that are needed to work with these kind of code bases will remain too. So in 5-10 years, we will still have something that's going to resemble an IDE. Now, how much is it going to be used? That is the question. As much as we today still have assembly and things at that level of abstraction, they're not very widely used anymore. And arguably, I think we're heading in the same direction where the tools of the trade will change to this higher level of abstraction. And the key driver here is actually parallelism. So as agents get more and more autonomous and can do more and more work with sort of more concise, higher value specification of work, we will need to do more things in parallel to turn this into productivity. And IDEs really are built to do one thing deeply at a time and are not necessarily fit for a world where you're going to do 5 things at a time. And so you now have to find flow in doing 5 things at a time. And you'll have to bring the context switching costs down to make that tenable. So concisely, the role of an engineer fundamentally doesn't change. The way we operate, I think, will very fundamentally shift towards doing multiple things at the same time.
Yes, fully agree. And I think it will be important that there will be tools for the task that you're facing at hand and to solve that. And at ONA, we believe some of them might be really you fire off an ONA session, and the task is potentially done in a fully autonomous fashion, and then you review. There might be things where you interact with VS Code in the browser, and there might be tasks where you jump on and go back to that, like lovingly crafting every single line of code, because that is what the task requires. And I think it's really about that continuum where we want to offer and also build tools for that to make that exciting. And Patrick, you've been with us now for several years. And have seen, I think you're also very involved in the GitLab community, so have very deeply immersed in the software development life cycle in general, and have seen a couple of trends there as well. Talk to us a bit about what is actually required from a dev environment perspective, from a regulatory perspective, to get let's call it agent developer or agent ready developer infrastructure in place at an organization like Kingland.
Yeah, absolutely. And I think some of that goes back to a little bit why we first started using the ONA platform, which we actually started using before ONA agents were a bit of a thing. And for a while, we've kind of tried to minimize the number of times that it works on my machine is said when you deploy something, right? This is always a bit of a joke in software engineering, but every joke is based a little bit in reality. And so for a while, we were using essentially virtual machines on very, very powerful development machines to create our code. And this was both because we could control what happened inside those machines. It was easy to rebuild those machines when a developer broke their development environment, because it is always a question of when, not if. And it allowed us to have a more controlled environment. And again, with the regulatory backing, not just CMMI 5, but also ISO and SOC 2, these types of controls are very important. But we ran into scaling problems with it. So as the number of engineers scaled, as the number of technologies scaled, you ran into issues where one person's virtual machine might have 3 different versions of Python installed, and those 3 different versions of Python are used in 3 different applications. And now you just have random developer errors because you wound up with the wrong version of Python. And so you'd lose hundreds of hours to that, if not thousands of hours. And so we looked for a better way. And that's where we really started to discover these CDEs with, at the time, GitPod, now ONA, being one of the lead contenders for that, which allowed us to essentially treat our development environment as code. So just like we treat our infrastructure as code to make sure that every time we do a deployment, we have a repeatable and reliable deployment cycle. Well, now we treat our dev environments as code. So every time we spin up a new dev environment, we have a repeatable and reliable environment. And that really launched our ability to scale our engineering, because again, now you've got each of these teams, each of these products that has their own dev environment that can scale. And as we look forward into how does that work with agents, and I think kind of Chris mentioned it too, you need to have this ability to scale your dev environments in order to start really being effective with agents. Because if you have an agentic flow and you're running it on your local machine, you're basically limited to how many environments you can run on your local machine at once. And you always have this danger that there's a blast radius of the agent making a change outside of the project that you expect it to. We've seen the horror stories of accidentally wiping databases. We've seen horror stories about people's machines getting corrupted.
Yeah.
Well, having this CDE environment has really allowed us to implement more of this agentic flow without some of those concerns. Because if it breaks an ONA environment, whoops, we just create a new one. And so this really allows us to treat our dev environments the same way that we want to treat our infrastructure, which is that it's reliable and it's standardized, 2 things that are incredibly important for regulatory needs. It also has very clear boundaries. So we're very, very proud and happy of what we've managed to do with that setup and how it enables us to scale into this agentic future.
That makes a lot of sense. Given you're quite and have always been very forward-leaning in adopting also new technologies, and what would be your advice to a company that is starting to look at it right now? How should they approach it?
Yeah, absolutely. Obviously, as you're looking at agentic tools, the security of the backing models is vitally important, right? So making sure that you understand where your data is going with these tools is absolutely something that you should be looking at. Yeah. And again, as you look at leaning into these agentic flows, it's best to assume that you're going to want to be able to run multiple of them at once eventually. So as you look at adopting agentic tooling, realize that almost a precursor to adopting that agentic tooling is making sure that you really have that good repeatable dev environment experience. So one of these solutions layers on top of the other.
Yeah, that makes sense. All right. Are there any questions from the audience? So feel free to put them in the chat. I think we had one. So Chris, maybe you can take that. So Chant asked if we've been able to observe the types of knowledge the owner agent squads and individual agents are learning through interaction with human developers, pointing a bit at memory, I think.
Yeah. Agentic memory is a very interesting topic that I would say overall as an industry is also still quite at the beginning. Like there are a lot of interesting ideas around. I wouldn't say this is pretty far from a solved problem. So this idea that agents sort of over time, our self-improving is something that we all want to be true, but in practice find to be very limited, even with the cutting edge techniques out there. The inverse is very true, though. What we do find is that as users start to use agents more and more, they get better at using them. So agents themselves are a tool like any other, except it's a really, like, that was not quite right. Agents themselves are a tool, an incredibly sharp tool. And like, I've been writing software for more than 25 years at this point, and this is by far the most game-changing tool I've ever come across. And yet it's a tool. There's a learning curve to it. You get better at using it over time. The number one mistake we see folks coming to agents, any agent really, make is that they underspecify the problem. There is this almost implicit assumption that an agent can read your mind. It cannot. Like, be as precise as you can. Even say the things where you assume that it should know that. And over time, we see users develop more of a sense for how they should prompt to get most out of the agent. Patrick mentioned that earlier, where more senior folks tend to also prompt better because they can make assumptions more explicit and they can decompose problems better. And so there's that learning curve that comes with it. It's not a steep one, but it exists.
And I might jump in here too as well, and talk about, there's, I think, increasing support for what's called the agents file that allows you to kind of strengthen this feedback loop, where you write a prompt and that prompt is, let's say, not as explicit as it probably should have been, to Chris's point. And so the agent goes off and it does something and it didn't do what you expected it to do. Now, you can refine that prompt, render that assumption explicit, and it'll go back and it'll fix its mistakes. But then you can document those assumptions inside the agent file. And that sort of, to Chris's point, like, these agents, they don't learn independently, but it sort of mimics that feedback loop where you render those assumptions explicit, you document those assumptions in the agents file, and then that makes sure that in subsequent prompts, those assumptions are rendered explicit. And this is also a great tool for helping teach your incoming engineers, because you'll find that these things that you want to render explicit for your agents, they're the same things, the same assumptions that your incoming engineers that you're onboarding need to understand about your code base. So it's very, very helpful, not just from a agent training perspective, but also from a onboarding engineers perspective as well.
Fully agree. We see that. We just onboard a couple of engineers, how quickly they're able to navigate the code base by essentially having, somebody sitting with an owner that can help them answer almost all questions about the code base. Is really amazing to see. There is a question around how does owner help with product management. I want to rephrase it a bit and tie it back to the initial question we had around also how the role of an engineer is more and more connected to the core role description that it always has been, which is also connecting with the customers and having a certain product engineering understanding. So how does a tool like Ona help engineers essentially becoming a product engineer?
We see this show up in two ways. One is sort of code adjacent activities, things like changelog, documentation, but also inquiries where you have, say, customer support or, again, engineering adjacent roles that need to know how something is built, who can now use Ona agents to inquire the code base and ask these questions and get an accurate answer that also, proves out here's where it's implemented. So we see a lot of that. There's also some element of product management, to bring it back there, is the synchronization with developers. How expensive is it to build something? What's the investment we're going to make? And as much as we want engineers to move in that direction, we also want traditional product roles to move in the engineers' direction. And this is where owner agents is extremely helpful, because it gives product managers the tools to get at least an inkling of what an effort might be.
And in addition to that as well, as we look at expanding like MCP server integration, this is something we're exploring a little bit more over the course of the next couple months, allowing your product management tools, which and your product management data, which may be stored in a completely different tool from your source code tooling, to actually interact and to work together, actually allows you to do things like have far more explicit acceptance criteria for creating stories for your engineering team. And we see a strong correlation between better acceptance criteria and more accurate estimation, for example, right? Allowing these things to, and like Chris said, to kind of come together and to reduce the friction in the communication, increases productivity and reduces error. So it's great.
I agree with that. All right, there is another. We can let's add 5 minutes and answer the remaining questions. This one I like. So, will we ever get to a point where regulated industries, in particular, given all the audit requirements and compliance requirements, can rely on fully autonomous pipelines, or will having humans in the loop always be essential? So, thank you, Sophia, for the question.
This one's probably for me. Let's use the crystal ball for a little bit. Do I see that future in 5 to 10 years where regulated industries can rely on fully autonomous pipelines? No, I think that there will need to be a human in the loop for a while, and I think that that's okay. But 20, 30 years down the line, the story might be different, right? I do suspect that we'll get to a point where certain lower risk tasks could be automated, but fundamentally, at the end of the day, a lot of risk and compliance is about judgment calls. I mean, AI is going to make a different judgment call depending on how you prompt it. So, and if you have the temperature set high enough, it'll make different judgment calls with the same prompt. So, do I see a world in the near future where a human is not in the loop? No, I don't.
There are adjacent industries that I think are a really good data point here too. If you look at manufacturing, where like arguably AI is the automation to the creation of software, much like industrial robots were the automation to manufacturing. And when you look at manufacturing today, there are very, very few factories that are actually truly lights out, where things happen without any human intervention or oversight. And that's 30, 40 years after we started automating production lines. And I think something very similar is going to happen to software, where humans will remain in the loop, and the level of abstraction in which they operate just gets higher and higher, and the value and sort of output that they have grows significantly, yet they remain in the loop. Also, Jensen's principle is very active. Like the cheaper we make something, the more we do of it. And so the cheaper we make it to produce software, the more software we'll produce, and the cheaper we do that per unit of human attention, the more units of human attention we'll consume.
Yeah, I fully agree with that. And I think when we speak with our customers and also onboard them to ONA, one mental model that works really well for now is that treat ONA agents in a way as your personal team of software engineering agents. They're there to amplify like your output, but there is still like a review and verification process in place, as it always has been. That's the beauty about software development. We have already established those review and SDLC patterns that you can rely on. So I think the human will still steer and will make those judgment calls until regulatory regimes change, etc. But the human will also remain, I think, on that side a bit of the bottleneck. So if history is a bit of a predictor of the future. Things are changing slower, specifically when humans are involved, and that definitely applies, I think, to regulatory and compliance regimes all over the world. Okay, great. I mean, time flew by. Any final comments, thoughts, anything you want to leave the audience with?
I mean, from my side, you know, I've mentioned this to dev teams internally, but it's always good to say that I think, you know, the most powerful agent is the one that's in the hands of an expert engineer, with you know, dev environments that can scale and are safe to use. And so I think you know, Ona is a great product that allows us to do this, but I'd also love to give a shout out to my engineering teams for doing great work,
Yes.
and for enabling us to be at the front runner of these technology changes. So it's a shout out to you guys for a great product, and a shout out to my engineering team for just being great. So
I'll tag on to that. There's the old saying that the future is already here, it's just not evenly distributed. And I think that's extremely true right now, where there are a lot of engineers that simply haven't tried agents yet. Still believe that tap autocomplete is the pinnacle of AI and software engineering. And you're truly missing out. And Ona Agents is clearly the best way to try this. So head over to ona.com and try it out today.
Chris, we should get you in sales, I think. I mean, somehow you
Everybody's
are,
in
right?
sales.
That is, wow, that's like that from our CTO. Amazing. You made our VP revenue very happy right now. Yeah, I want to end with a big shout out to Patrick, yourself, for the continuous partnership over the years. I think you've been very instrumental in shaping also our direction and giving us insight. And to all of the Kingland engineers as well, I think it has been a pleasure to work with you over the last years, and we're very much we're very much looking forward to continuing that partnership as we are venturing in that new and very exciting world. So thank you for coming today, and have a great day, everybody. Bye-bye. Thank you.